All right, hello. As Kim said, my name is Nathan Keys, and so a lot of the talks at this conference are about using this equipment in sort of an oceanographic sense. The world we live in is a little bit different, so we use them in the world of marine construction. And so today we're just going to talk about how we use the Teledyne sort of lineup in that application. Yeah, so Kim touched on most of this. So, I've been working for Mesotronics for about 7 years now, and so, in and around the marine construction industry for that whole time. So, when it comes to marine construction, you can sort of broadly break it down into 3 phases. And so, the first one is the pre-construction phase. So, this is when they've maybe won a project or they're going to start a project, and we want to basically gather some data, figure out what's going on the bottom so we can do a good job of cleaning it up or whatever it is. So this one's all about information. So we want more information so we can do better planning. The next one is when they're actually doing the construction or deconstruction. And so here we're doing like condition kind of surveys, real-time guidance for doing the construction accurately and making sure it's done. There's as building, which is a term we've sort of been pushing. So that's as they're actually building it. You'll see some in videos in a minute. We get some real-time sonar updates. And also as the project is moving forward, if they need to make any sort of adjustments to the plan or anything like that, it happens in this phase right here. And finally, post-construction. So, this is also sort of like monitoring maybe. So once the construction is complete, we want to just make sure everything is holding up as we expect. And so these are like the as-built surveys, structure monitoring. And if there's a problem, we can find it in this phase. And if we do find some sort of problem, then it's more of a loop than a linear function. If we do find a problem, then it starts back over at the pre-construction, and it just goes like that. So I just want to introduce some of the different Teledyne products that we use in these applications if you're unfamiliar. So the first one here is the Teledyne BlueView BV5000. And so this one it's very small, and they have it on the dock over there, I think, if you want to check it out. But it's very small. There's a couple things. It's got a really high resolution. It's 1350 kilohertz. So that's high resolution, but the trade-off there is lesser range. So it will only go out to 30 meters, which is about 100 feet. So if you need to get longer than that, this isn't the tool. So if it's something small and somewhat close to you, you can get some really good imagery, some really good resolution, and we'll see that here in a little bit. The other thing is you can kind of see the sonar here. It can be mounted on a pan and tilt mechanism, and so the pan and tilt. This is just a short video of it panning and tilting, but basically the strength of this is it lets us point the sonar wherever we want. So without having to move the vessel, move the boat, we can turn it, and we can also sort of pan it up and down with a click of a button. So without the pan and tilt, you have to either physically rotate the head, or you can do some steering of beams, but there's a cost to that and accuracy. So the pan and tilt really gives us a lot of flexibility there. So BlueView is good because small, close range, and very high resolution. The pan and tilt gives it a bunch of extra functionality. Okay, so then we also use the Rezon T-Series here. The T50, many of you are probably familiar with it, state-of-the-art kind of sonar. It's got a really small beam angle, and so that gives you really good resolution on the bottom as well. Got a nice wide swath coverage, super clean data coming out of it. So we use this a lot for like the precondition or the as-built surveys, things like that. So here's just an example. We had both of our boats in the same place, and so they're both running a T50 here, and so you can just see kind of the wide coverage that they're able to get. And when they're both going to scan a sunken barge here, it's an artificial reef, and so you can just kind of see. And so on this one, no pan and tilt, so we're just driving right over. We're moving the vessel to create the surface, and so you can just kind of see them come together there. So that's a T50, really good sonar, really clean data, wide swath. The other one we use is the T20, and so it's sort of the little brother of the T50. A little bit bigger beam size, but it's also a little smaller, a little bit more compact. So this one, we're still getting all the same bottom tracking algorithms, the same clean data coming out, but it's, it's a little bit smaller, and so with this one, we're able to actually put it on a pan and tilt as well. Looks something like that, and so it gives us that same freedom with the blue view. And so the blue view, we talked about how it's short range and sort of small sector with the T20 on a pan and tilt, and that is the T20 on a pan and tilt there. With the T20 on a pan and tilt, we get all that nice wide coverage. We can still pan it and tilt it around however we need to. And so this one is fairly new, and we're using it quite a bit and getting a lot of really good data with it. So I just wanted to also mention that either the T20 or the T50 you can put in dual head. I don't have any of that for you here today, but you can put them in dual head configuration, and then we really are getting a lot of coverage, right? So we got almost twice the coverage. So if you're looking to map a huge area, you could do it as a dual head. Okay, so now I just want to kind of go through and show you some examples of how our customers have used the Teledyne lineup in these different phases. And so we're just going to start here with the pre-construction phase. So this contractor, so this is T50 data that you're going to see here. And so they're building a bridge. And so they have to put a bunch of piles in. And so this is a submerged, sunken bridge that I guess somebody had just left there. And they're scanning it here, and this is just the Reason interface that you're looking at. They're scanning it here, and so there's a couple things, so in nice, flat, even ground, it's easy for the bottom tracking to filter out bad data. But even in data like this, where there's all these anomalies and things like that, you can see the yellow line there on the top and the bottom as it's sort of following all those different features. It's still filtering out most of the noise, and so the data is still coming across very cleanly. So basically, they wanted to find if there's anything down there, if there's anything in the way, and make sure it's not in the way of any piles they have to drive before they start driving. So this is some good imagery, but it doesn't really tell you where the stuff is. So they integrated it with the Teledyne PDS software, and so this is kind of that same run, but in Teledyne PDS. And so in the lower left there, you can see that's just the current swath. Upper left is a plan view, and then the right side is just the 3D point cloud. And so now all this stuff is being geo-referenced with there's a Planix POS-MV on there. So we're sending all that information over to Teledyne PDS, who's tying it all together. And so now we've got like a geo-reference kind of map point cloud of where all this stuff is. So in this case, the bridge they're building is just kind of represented by, so those lines over there, there's an existing bridge, and then they're going to build one right next to it. And so they'll be able to take this point cloud, overlay the pile plan on top of it, and see if there's any sort of anomalies or anything in there. So pre-construction, before they started, they just wanted to see what was going on down there. Another contractor here, so up at the top, that's a LiDAR scan that they did and of a bridge. And so this bridge they're going to replace it. So the question was how to replace it. And so there's water all around, and so they did a survey, again using the T50. They did a survey of the area, you see in the lower right. And so the question was, can they build the bridge and then float it in on the water? Or do they have to come in on land? And if they come in on land, they're going to tear up all that land, trying to move the bridge and all that. And so they found out that, it does get kind of shallow in the dark orange there, but they can kind of slip through that little yellow part. So they figured out they could do it, and that's how they bid the project like this, like floating it in. And it turns out it was quite a bit cheaper, a lot less damage to the land, and so they were able to win the project based on having this survey done, and they were able to make sure that they were going to be able to do it. So, yeah, they used that to win that project, and they're working on it right now. It's another contractor here. So this is like a marina, and so on the right-hand side, you can kind of see the grid model there, and there's some logs kind of right where the excavator is there. You can see there's some sort of big green long items there, those are logs. And so the idea was they're going to dredge this out, but before they do, they have to remove these logs. And so they did a survey, and we were able to locate all the logs with the survey, so they can, they also have guidance on this excavator, so they can move the excavator right over the surveyed log, pick it up, get it out of the way so they can continue dredging. So this one is done with a T20, and it's kind of hard to see with the lights, but there's an anchor in the center of each of these pictures. And so they found this anchor, and this is a bridge demolition project. And so basically in the contract it said, okay, demolish the bridge and pick up all the trash and get it out of there. And so they did the scan before they started. They found this anchor, and they found a bunch of other stuff too that was already down there before they started. And so they were able to go back to, whoever awarded the contract and say, hey, there's stuff down there that we didn't put down there. Do you want us to remove it? And this is what it would cost to remove it, right? So otherwise, once they start cleaning up, they run into this anchor afterwards. There's no way to prove that they didn't put it there, right? So at this point, they're able to, charge for their work. Otherwise, they would have had to just kind of do it on their own nickel. So having this pre-survey before they started allowed them to find these things, make a little extra money. So this is in the Columbia River, and again, the T20. So there's a sunken tugboat, and the first thing they had to do was find it, figure out where it is. They knew it went down. They kind of had a general idea of where it is. So they surveyed that whole area with the T20, and we were able to find it. So you can kind of see it there on the right, and you can see there's like sort of some scour happening around it. Then this on the left here is a point cloud of it. And so in the point cloud, you can go in and sort of measure it. You can also see which way it's sort of oriented. So it's upside down, aft, bow up, upside down. So you can kind of see the propeller at the bottom there. So now they have a really good idea of where it is and which way it's facing. And so the idea is they're gonna take it out, right? So they're gonna build a cofferdam around it and remove it. But to have this information, know exactly where it is, know exactly which way it's facing, just helps them do the planning a lot better to get this thing out of there. So that's some pre-construction stuff. There's a lot more use cases, but those are just some that I was able to get the data for. So now we're just going to the construction phase when they're actually doing the building or demolition or whatever it is. So this is that same contractor that was pulling the bridge down. So they were using hydraulic jackhammers to beat the bridge down and for the underwater surfaces. So they had a T20 on a boat, and the boat would go by and do a scan just like you're seeing now. And so the scan would show, so they had some certain level that they had to beat everything down to basically, and the scan would show have they met that level or not. And so if they have met the level, then a clamshell crane would come in, pick up all the rubble, and they'd finish it that way. If they hadn't met the level, then they could send this information back to the excavator, and the excavator can finish what he hadn't done. So they're doing this from a boat. They've got a bunch of excavators, a bunch of cranes out there, so this one boat servicing a bunch of them. There's a few other ways we can do that, but for now, that's just one way. So the boat is sort of, as they're destroying it or building it, the boat is giving them sort of real-time updates. So this is a contractor using a blue view mounted to a construction barge, okay? And so what's gonna happen here, so the construction barge, if you're unfamiliar with it, is real big and real heavy, and it costs a lot to move it, right? So they have to move it to start digging in other places, but if they can minimize the barge moves, that's a lot of money saved. And so with the sonar on the front, so this is a clamshell crane has been digging a bunch here. And so we got the sonar on the front. On the left is 3D and just colored by elevation. But on the right, it's colored by distance from the design grade, so what they're trying to build. So anything in the green and yellow is in their tolerance, that's good. That sort of brown color up at the top means it's too high, and anything that's red is too low. So he can do a scan here like this and say, okay, I've got some red, I've got some more work to do before I move on. So it just helps them save some of the barge moves and things like that. So this is what the sonar operator would see. And then, the guy operating the crane, he would just kind of see it like this. So that's the crane screen there. So this is what he's using to dig. But if you watch kind of right in that red circle,
Is that on a tripod?
no, it's mounted to the front of the barge. So there's like a pole on the front of the barge, and it's just spinning that way. So that for this one, we do have to measure it and position it. And so that just sort of pops in there for him. The colors just kind of come in. Let's do it again. So the colors just sort of appear like that. And so this is what the crane operator sees. And he just says, okay, I got a little work to do here, a little work to do there. And he can address it before they have to move. But you can also see here, so this is the blue view, and we talked already about how the blue view has some limited range, right? And so for this clamshell crane, in this particular project, they were just, that's a slope on the right-hand side, and that's all they were really worried about. But you can see that the swath of the blue view didn't even make it to the other side of the barge, right? So this is a huge barge. It's about 100 feet wide, and so it didn't quite make it. So if they were trying to use the entire working end of the barge, the blue view might not have been the best choice. So that's where the T20, you can use that to get that greater range, the greater swath width, and all of that. And we'll see some of that here. So this one is a pretty interesting one. So they were placing some material, or they were placing some rocks at the footer of a bridge because it had scoured out pretty badly. And they wanted to have the sonar again on the front of the barge to make sure that they put the rocks in the right spot and enough rocks. And so this is the blue view one more time because it was real short range and it worked out really well for them. But for this one, they had to hang out under the bridge. And so GPS doesn't really work under the bridge. So we were using a total station, and we used a Teledyne gyro compass to do heading, and it was a pretty cool project. But yeah, again, so they're making sure they place a bunch of rock, and then they scan it with the sonar, and the sonar tells them, okay, yes, that's enough rock, it's too much rock, or not enough. And I just wanted to show that, so that sort of surface, that surface on the upper left there is provided by a multi-beam from a boat, so real high-res kind of stuff. And the one we have on the front of the barge, so basically here, the little speckled area is the swath from the sonar. And the point is that they're the same color, right? So they're matching up well. And also you can kind of see running through the center there is a cable crossing, so you can kind of see the little mound. And so you're getting a little bit better resolution on the blue view. You can see some of the points stacked up on that mound there as well. So that's that high resolution we were talking about. As long as you stay within those distance constraints, you can get some really good imagery. So I mentioned that for breaking down the bridge, there's some other ways we can do that. So instead of having it on the boat for this one, we put it on a barge. And so the barge is doing the same scan here. This is the T20 on the pan and tilt. So you can see it's got plenty of range out there. It's covering all that. We can get that same data, and now he doesn't have to wait for the survey boat to come by and do it. He can just get that. It just, I mean, so you saw it there. It took about maybe 10 seconds to do that scan. He has all that data in real time. He can see if he needs to do any adjustments or anything like that. So this is a T20 on a real big cutter suction dredge. This dredge, the ladder is about 80 feet long, so it's pretty big. And so what you see there in the upper right is the plan view. That red line is the coverage of the sonar. And as the dredge, so this dredge works like this. It just kind of swings back and forth. And so as it swings, the sonar is just pointed straight out and updating the surface. So you can see you can see it pretty good in the lower right. As it moves left, the colors change based on where the sonar is. And so they're able to see the stuff they've already cut, the stuff they're cutting right now, and the stuff in front of them. The other thing that's cool, because it is on the pan and tilt, so the red line, you'll see him here, he'll turn it around. And so this is like a click of a button. He's able to rotate that where the sonar is looking. And the dredge operator or the dredge captain made a comment. He said, okay, it's good when we're going left because it's on the left side. But when we go right, we're going to miss a little bit. I said, that's a good point. So we used the pan and tilt, panned it a little bit, and we pointed it to the right side. And now, whichever way you're going, you can point it however you want. So the pan and tilt just gives you a bunch of freedom in that way. Okay, so finally, we're going to talk about the post-construction phase. So once all the construction is done, so you might also call this like monitoring or something like that. So in this project here, They're inspecting this pipeline, and they just want to make sure that, first of all, the pipeline's intact, everything's looking good, and there's no debris laying on the supports, there's no issues. So this is the BV5000 again, the blue view, and that 1350 kilohertz really gives you some nice imagery. You can see the blocks and the straps holding the pipe on there. So short range, high resolution from the blue view. So this is a paper intake. So it's a paper mill, and they intake water from the Columbia River. And so we dropped the blue view in on a pole, so not a tripod, but just on a pole this time. And we did a bunch of scans in there, and then we stitched them all together. And so basically what they're looking for is sediment buildup, or like you can kind of see in the one on the right-hand side, upper right, there's some logs in there. So if there's material or debris in there, they want to find it and they want to get it out of there. And so, yeah, on the upper left there, that's just like a Google Earth image of the intake. So Columbia River's below it, and that's just a picture. So you can see some grates there on the ground. So that's where we dropped the sonar through those grates on a big long pole. And we did a bunch of scans, and so here's just another view from the scan. So you can see there's some logs, and you can see the ladder there. And again, the blue view, if you stay within the range requirements, you can get some really good data. And this is cool. So this is just the pumps. So they're pumping the water in this way. So if the debris or the logs or the material gets into the pump, it's a bad deal. So that's why they want to get them out of there. But I just thought it was some good imagery of the actual pumps there. And so this one, a hurricane went through in the Virgin Islands area, and they wanted to check out a pipe and just make sure that the pipe was okay. And so this sort of arc that you see on the left is a pipe opening. And then in the center, that sort of yellow area is a big indent where something crushed the pipe, and it's gone now. So there's supposed to be pipe here. There's no pipe here. So they saw this, they scanned it like this, and found out there's a problem, and now they're working on replacing this pipe. And so this one, they have, so basically they're scanning a sheet pile wall. So this is a port authority doing this. And so you can see sort of in the swath in the lower left, there's some buildup at the bottom. So they're looking for buildup, they're looking for scour holes. And so before they got this technology, they said they find the scour holes when the lawnmower goes over it, that the guy falls in a big hole. And there's a better way to find them, right? So this is a little bit more efficient way to find the scour. So they're just doing a sheet pile wall here and just making sure there's no buildup and no scour. And so you can kind of see now, I think, from how the post-construction kind of also flows into the pre-construction. So if they're watching it, they're monitoring it. So if there is a problem, then they can flip over to the pre-construction and figure out how to deal with it. And so that's pretty much all I have for you guys. If there's any questions, I'll happy to take them.
Teledyne Marine. Everywhere you look.